So you're probably familiar with a voltmeter such as this one, or a multimeter which can measure the voltage and the current. Or here I've got a differential voltage probe. Now all of these work by measuring the potential difference between 2 points on a circuit. So these all need to be connected in parallel with the component which they are measuring the voltage drop across. So for example, in this circuit diagram here, if we wanted to measure the voltage drop across the resistor, we'd need to put a voltmeter in parallel with that resistor. Now, voltmeters have a very high internal resistance, and this is so that they don't change the behavior of the circuit that they're measuring. So for example, in this circuit here, imagine if our voltmeter had a very low resistance. Well, then more of the current would pass through the voltmeter than would pass through the resistor. And so we'd be changing the behavior of the circuit by measuring it. So that is not going to be an especially great experiment to do. Now in most circuits, so the 0 point for the voltage is taken as the earth, which is also known as ground. So ground or earth have a special symbol in electric circuits which looks like this. So earth or ground is exactly what the name implies. In an earth circuit, it's connected to the ground via a conducting materials. So often we'll have a metal pole which is driven down into the earth. Then as the earth is so large, it can act as an almost infinite sink for electrons or source of electrons. Now on power outlets such as this one, the third prong is actually connected to the earth. Earthing circuits is a really good idea, as if there is a sudden rush of current through it, that rush of current will pass directly to the earth. If it wasn't earthed and you touched the circuit, that current would pass through your body to the earth, giving you a possibly dangerous electric shock.